Second part of section 9.1 is to count the elements of a list. So for instance, if I ask you how many integers are there from, say, 5 to 12, okay, 5 to 12. If you just 12 minus 5, which is 7, then you're counting it wrong. Let's say, suppose you have 5, 6, 7, 8, 9, 10, 11, and 12. If you count that carefully, 1, 2, 3, 4, 5, 6, 7, 8. There were actually 8 integers from 5 to 12 inclusive. So if you, the formula becomes, if 12 minus 5, which is 7, will miss 1. So you will have to add 1 to correctly count that. Now, of course, that's not a rigorous proof, but that's showing you how you can actually count. So here's the theorem that we'll be using. If m and n are integers and m is less than or equal to n, and how many integers from m to n inclusive, including m and n, there will be n minus m plus 1. Don't forget to add 1. Now, how do we use these results to count? So let's look at first example. How many 3-digit integers? That means 100 to 999, right? Those are all the 3-digit integers that are divisible by 3. Now, how do we count? So I'm gonna, there are different ways to count, but in here, because we try to use this theorem, so we are gonna use the following way. So I'm gonna list a few numbers. So 100, the next digit is 101, the next digit is 102, and this actually is the first integer, 3-digit integer that's divisible by 3, because 1 plus 2 is equal to 3. As long as the sum is a multiple of 3, that number should be divisible by 3. And the next one is 103, 104, 105. This will be the second integer that's divisible by 3, and so on and so forth, okay? And of course 998, well, 99, let me do it, 996, 997, 998, 999. I know this is divisible by 3, this is also divisible by 3. Now, how many are there, okay? So now, if you look at the first number here, 112 is equal to 3 times 34, okay? And 105 is 3 times 35. The next one in line, which is 108, this will be 3 times 36, and so on and so forth. Okay, this will be 3 times 332. The very last one will be 3 times 333. Now, basically, how many are there? Do you see that this kind of tells us? So all these multiples of 3, they are 3 times 34, 35, 36, and so on and so forth. The last one is 333. So how many integers are from 34 to 333? That will be the count for how many 3-digit integers that are divisible by 3. So therefore, here's the count. 333, which is the last one, minus the first one, 34, and don't forget to add add 1. So this gives us 300. So that's how many integers that are divisible by 3 from 100 to 999. Now, what is the probability that a randomly selected 3-digit integer is divisible by 3? Because we are saying that one integer is randomly selected from this list. We assume that it's every single number has equal chance to be selected. So therefore, we are going to use the rule that we just introduced, which is this rule, equal likely probability rule, right? So therefore, we are going to say how many integers are divisible by 3? There are 300. And how many integers are from 100 to 999? There actually will be 900. So therefore, it's going to be 300 divided by 900. Why 900? Just do a little quick count, right? So how do we count how many integers are there? 999 minus 100. Don't forget to add 1. So we have 899 plus 1, which is 900. So therefore, as we simplify this, it's going to be 1/3. Now, let's do a few more exercises. So the next one is, if the largest of 34 consecutive integer is 316, and what is the smallest of these 34 consecutive integer? So what's the first one? So now suppose you have a whole bunch of integers, so each dot represents an integer, and then each cross represents an integer, okay? And then now the very last one is 316, and then there are 34 of those, 34 integers here. The very last one is 316. And what is the smallest? Smallest is the first one. Let's call it x. Let's call it x, okay? And according to what we just introduced, how to count, so we know that 316 minus the smallest one, don't forget to add 1, and we say there are 34 integers. So therefore, we can set up an equation like that and then solve for x. So when we solve for x, this is negative x plus 317 equals 34, and x is going to be 317 minus 34, right? Which is 283. So therefore, the smallest integer will be 283. Now, let's look at another application. A non-leap year, that means 365 days. Assuming January 1st is a Monday, then let's count how many Thursdays are there in the year. Of course, this question can be changed to how many Fridays, how many Saturdays, how many Sundays, right? So let's just do the how many Thursdays are there in this year. By the way, they may not be all equal, okay? Now, so I'm going to list a few numbers. So suppose this is January, the first day of the year, second day of the year, third day of the year, and fourth day of the year. Because it starts with Monday, January 1st, which is the first day of the year, is a Monday. So this will be Monday. And therefore, this is Tuesday. The next one is Tuesday, Wednesday, Thursday. So this is actually the first Thursday, right? And then, of course, what would be the next Thursday? It will be, you add 7 days, and this will be the second Thursday. Okay, this will be second Thursday. This is the first Thursday, second Thursday. And what is the next Thursday? You add 7 to it, which is 18. And what's the next Thursday? 25, right? And so on and so forth. Now, let's try to find a pattern. The first, they all differ by 7. So I know the first one, which is 4. The next one will be 4 plus 7, because there were 7 days in between. The next Thursday will be another 7 days in between, right? Another 7 days in between. That means there will be 2 of the 7 days from the first Thursday, right? So therefore, it should be 4 plus 2 times 7. And of course, the next one will be 4 plus 3 times 7, because from the 4th day of the year to 25th day of the year, we have 3 weeks passes, 3 weeks in between, so 3 times 7, and so on and so forth. Now, 361, 362, 363, 364, 365, and so on and so forth. And actually, this turns out this guy is 4 plus 3, 51 times 7, which is 361. So you have to do a little algebra to verify that. And that will be the last Thursday because that's the 4 plus a multiple of 7 you get to here. Now, the first one, let's look at it as 4 times 0 plus 0 times 7. The next one, we say it can be viewed as 4 plus 1 times 7. And the next one is 2 times 7, 3 times 7, and the last one is 51 times 7. And we want to count how many. Basically, we're counting how many integers are from 0 to 51. So this is like how many integers from 0 to 51, right? So the way we count will be 51 minus the smallest integer, which is 0, and don't forget to add 1. So therefore, it's going to be 52. And this would not surprise you because there are 52 weeks in a year.